Hi, my name is Jake, and I'm one of the SI leaders for Math 130. Today we are going to talk about simplifying and solving inequalities. Okay, so here's the problem that we have. X squared minus 7x minus 18 over 2 times x plus 1 is greater than or equal to 0. Okay, so the first thing you want to check to see is that this fraction that it gives you is in relations to 0. So here we have this fraction greater than or equal to 0. This means we don't have to move everything to one side, find a common denominator, and simplify. This is already done in this fraction. So once you get it like this, you want to completely factor everything in this fraction. So if we factor the numerator, we get x minus 9 times x plus 2, okay? And then the denominator is already factored for us, so we just have 2 times x plus 1 greater than or equal to 0. Now what you want to do is set each term in this fraction that involves the variable equal to 0. So we're going to have x minus 9 equals 0, x plus 2 equals 0, and x plus 1 equals 0. We don't have to worry about the 2 because it doesn't involve the variable. So we solve each of these for x. We get x equals positive 9, x equals negative 2, and x equals negative 1. Okay, so now we want to draw a number line with these points on it. Okay? Then what you want to do is go ahead and write the intervals up here that are represented on this number line. So this interval here is negative infinity to negative 2, and then you always look to see what relation this is to 0. If it's greater than or equal to, or if it's less than or equal to, you use brackets. If it's strictly greater than or strictly less than, you always have parentheses. So this tells us greater than or equal to 0, you have brackets. But one thing to worry about with fractions is that you can never include values that make the denominator 0. So we can't include negative 1 in our intervals. So everything's going to have brackets except the negative 1. So we put a bracket around negative 2. Once we get to negative 1, it's a parentheses to 9. 9 gets the bracket, and then bracket 9 to infinity. Okay, so we've written all the intervals up here. So now what we want to do is pick test points in between each of these intervals and plug them in. So let's pick negative 3. Okay, so we're going to plug it in here to our fraction. So if we plug a negative 3 in for x, this term is a negative, this term is a negative, 2 is always going to be that positive, and x plus 1, when you plug a negative 3, that gives you a negative. So there's an odd number of even signs, so that always means it's going to be, there's an odd number of negative signs, so it's going to be negative. So this whole interval is negative in between there. Okay? So let's pick one between here. Let's do negative 1.5. Okay? So if you plug a negative 1.5 in for all your x's, this one's going to be negative, this one's going to be positive, 2 is always positive, and this one will be negative. So there's an even number of negative signs, so that means this one's going to be positive. So I'll put a plus sign in between there. Alright, one between here, let's pick 0. If you plug a 0 in for x, you get a negative, a positive, 2 is always positive, and this one's going to be positive. So an odd number of negative signs means it's going to be negative. Okay? Alright, then we pick one here between 9 and infinity. Let's pick 10. So if we plug a 10 in for all of our x's, we get a positive for this one. This one's positive. 2 is always positive. This one gives us a positive. So this has no negative signs in it, so that means it's going to be a positive number. Alright, so the hard part's done. Now all you need to do is choose the intervals that are appropriate for whatever this relationship is. So we want to know the values of x that make this fraction greater than or equal to 0. So you look for the ones with the positive sign. So it's these two intervals here. So your solution is going to be -2 to -1, parentheses, union, this interval, 9 to infinity. This has been my explanation for simplifying and solving inequalities.